Hi there. All right, today I'm going to talk about one-dimensional arrays. So one-dimensional arrays are essentially variables that are lists of data values. All right, and each position in the list is referred to as an element, and it is numbered based on its position in the list, where the first element of an array is in position 0. The next one is in position 1. The one after that is in 2, and so on. All right, you refer to each element in the array as using the name of the array, then open square bracket, then its position, then a close square bracket. And because the first position has an index of 0, the last position is going to be in position n minus 1 if you have n elements in your array. All right, so arrays can only contain a single data type, and you specify that when you declare the array. You specify what kind of data the array is going to can be able to store. Also, arrays have a fixed length when you declare them or when you create them or instantiate them, I should say. Once you've created an array, uh, naming its length, you're not going to be able to make the array longer or shorter. All right, so as with variables, which we've used so far, you have to declare an array, and then unlike primitive variables, you have to, since an array is an object, you have to instantiate or create the array. Now, this line here, int brackets myArray, is how you declare an array named myArray that's going to store int values. To actually instantiate or create the object that the array is going to, or the reference to the array is going to point to, you have to use the new keyword. So once I declared the array, I could say, all right, my array equals new int bracket 10. Okay, and the number that you specify in here is how many elements you're going to have in the array. Now, you can declare the array and store objects or create the array or instantiate it all in a single step, and that would be like this line of code here. The first half of it declares the array, the second half of it actually creates the array. If you do attempt to make assignments to an array without having instantiated, you're going to get a null pointer exception error. So when you see that when you're working with arrays, chances are that's what has happened. All right, so for small arrays, you can actually declare the array and instantiate it and assign values all at the same time. And this would be the syntax for doing that. The elements that you list, or the values that you list separated by commas inside the array, are the values of the array, and Java will create the array, decide on the length based on how many values you have. So this line of code here declares an array called myArray, makes an object for it that has 4 positions, and the values in those positions or elements are going to be 4, 5, 6, and 7. All right, if you don't assign values when you instantiate or create the array, default values will be assigned. For object data types, null will be assigned to each position or element in the array. For int or short or byte arrays, each value is going to get 0. For float or double arrays, each element is going to be assigned a value of 0.0. And for Boolean, everything is going to start out as false. You can refer to the length of the array just like you can refer to the length of a string. and to do that, you give the name of the array and then dot length. Okay, for loops are frequently used to iterate through arrays or access each value that's stored in each element of the array. So typically you have a counter variable. You say I less than my array dot length and then I plus plus, and then you use the counter variable as the index in any assignment statement in the body of the loop. So these three lines of code are going to go through an array and assign values of 7 to each position in the array. This line of code right here, or snippet of code, is going to go through the array. It's going to check each element of the array to see if it's 4. If it is 4, it's going to add 1 to a count variable. And then this one here would go through each position in the array, and it would have to be an array of numeric values, and add 2 to what the value that was already in that position or element of the array. Okay, the downside of using arrays is that you can't change their length, which can be a problem because your program doesn't always know how big of a list it's going to have when you write the code for it. So one workaround is to always make an array much bigger than you need it to be, and then you create a variable that is kind of pointing to the last position in your list, and anytime you add a value to your list, you increment that last position so that you know how many elements you have in your array, and based on what the value of last position is, and last position is the index of the last element of the array. All right, some classic operations with arrays include one like this, which is finding out what the sum of all the elements in the array are. Searching for the first occurrence of a value in an array. Okay, notice it uses a while loop. It starts the index being -1, then starts at the first position, which would be position 0. Checks to see if the counter variables within the length of the array, and the value is not found. Then there's an if statement that's going to look and see if the element or whatever stored in the I position of the array is equal to the search value. Then it sets found equal to true and sets the index of to be that value. All right, this would be an example of searching for the last occurrence of a value in an array. All right, then the last thing is the enhanced for loop for an array, or which is used with arrays, or also referred to as a for each loop. So it provides a simple way to iterate through an array without having to reference an index variable. So the way it works is you say for, and then whatever your data type of your array is, you list the data type. Then you list a name of a variable that you're going to use, a colon, and then the name of the array. Typically, I use element as the name of the temporary variable that we're going to use. All right, then you don't have to refer to each position in the array using the index. You just use the name of the temporary variable. So like here, I have an array that has 4, 6, 2, -9, 2, and 8 in it. I make a sum variable called 0, and now here is my for each loop. I say for int element, for each element int element in the array, add element to sum. So this is going to go through and add up all the values in the array. Note that element, if you were writing this with a traditional for loop, you would say, instead of element, you would have ARR bracket I. Okay, so with for each loops, the code's a little simpler, but the limitations are the loop always goes from the first element to the last. You cannot use, you can't go in a different order or check only, every other item and element of the array. You can't make any assignment statements, okay, to the array if you're using a for each loop. You can't refer to a specific element by its index, and you can't, in an assignment statement, you can only reference the current element that the loop is on, not, the current element and one that follows it. So there are some limitations, but if you are just traversing through an array, looking for something or adding the values together, you can use a for each loop.